And a happy new year from Diffusion. The first show of 2017 is from 10 years ago, from the 12th of April 2007. Listen out for the prediction of how fast broadband in Australia was supposed to become by now. We're still at the same 10 to 20 megabits per second speeds, not the gigabits predicted, thanks to the policies of the Liberal National Party.
Diffusion, the international science radio show.
We have a bouncer on the doors of perception.
The good, the bad, the ugly.
It gets pretty exciting.
The myths, the truths.
Toxicology.
Astroseismology.
Magnetism. The dark side.
Genetically engineered potatoes.
Planetoid.
Planetoid.
I love that word.
Hello, I'm Tilly Boleyn, and you've just tuned into another episode of Diffusion, your internationally fantabulous science show, which is currently measuring 7.2 on the Richter scale down here in sunny Australia. This week, we've got so many exciting topics to cover, my head is spinning. Like how eating an Aussie pie can protect you from the sun's harsh rays. And speaking of rays, we'll also be chatting a little bit about lasers later too. But stay tuned, because straight after the news, we're going to get some scientific tips on how to get a good night's sleep. But right now, dear listeners, set your brain dial to incoming information as Ian Woolf takes the helm of this scientific expedition and steers us all in the direction of the latest news and views from the magical world of science.
Robotic fleas powered by rubber bands. Technology Review reports that researchers at the University of California, Berkeley are designing a millimetre-long robot flea that uses a tiny rubber band to spring 20 centimetres into the air. This is part of the development of the ultimate evil genius tool, Smart Dust. Smart Dust has sensors for light, heat, sound and chemicals. It communicates by radio with other specks of Smart Dust to form a distributed computing network. Smart Dust can be used to track people in natural disasters, to gather environmental data such as sniffing out pollution, in difficult or distant environments, and for all manner of scientific and surveillance purposes. Naturally, Smart Dust is solar powered. Real fleas can jump so high because they store their kinetic energy in an elastomeric protein called resolin, an insect spring. For robot fleas, it was simpler to use stretching rather than compression. A few years ago, the lead researcher, Sarah Bergbreiter, was adding legs to the Smart Dust project to let it walk. Now she's helping it jump with rubber bands a tenth of the thickness of a human hair. The legs can now kick, which, as well as getting the Smart Dust into the air, will also allow it to kick against other dust and move around. Through the radio network, the whole cloud of Smart Dust could move together. Working with Chris Stewart, she created a tiny solar cell array to power the device, a microcontroller to govern its behaviour, and a series of micro-electromechanical systems motors on a silicon substrate. These are inchworm motors, which draw two hooks apart to stretch the rubber band. Distributed sensors in the dust cloud can give you a bigger picture, which can be stitched together with software. Brain implants to help your memory. Popular Science reports that Ted Berger and a team of neuroscientists, mathematicians, computer engineers and bioengineers at the University of Southern California are designing a brain implant that could eliminate human memory loss. It can talk to brain cells like a native part of the brain. Ted Berger says, "I don't need a grand theory of the mind to fix what is essentially a signal processing problem. A repairman doesn't need to understand music to fix your broken CD player." His work since 1976 has been to reduce higher cognitive functions to a set of mathematical equations based on how neurons respond to stimulation. This mathematical language could then be coded into some form of prosthetic device to help our brains. The main target is the hippocampus. The hippocampus is part of the brain's central processing centre. It helps analyse sight, sound, taste, smell and touch, and stores the data as memories. Tens of millions of people around the world suffer from Alzheimer's and other diseases that attack memory. So far, we have a prosthetic cochlea which gives hearing to the deaf, and artificial retinas are in patient trials for returning sight to the blind. The BrainGate at Brown University reads signals from the brain's motor cortex to open or close prosthetic hands with a thought. All of these devices are one way only. Berger's brain chip communicates both ways, in and out. Their current chip models fewer than 12,000 neurons, compared with about 100 billion in the brain. The chip will be tested on the brains of live rats later in 2007 at Wake Forest University. Berger's brain chip can receive analogue signals from live brain tissue, convert them to digital signals, and then reconvert them to an analogue signal relayed to healthy neurons on the other side. Critics have pointed out that diseases like Alzheimer's cause damage not only in the hippocampus, but in other areas of the brain as well. In 4 years, they plan to start tests with monkeys, and they hope to have brain chips to help humans made available in less than 15 years. Hepatitis and chocolate together at last. Tasted at Dorkbot, New York City. First, there were plush, fuzzy microbes. Now, there are viral confections. Dorkbot are people doing strange things with electricity. They meet all over the world, even Sydney. Viral confections are chocolates shaped into the molecular structure of the hepatitis C virus. A plaster model of the virus was printed with a 3D printer from a 3D algorithmic illustration of the virus from the Protein Databank. The Protein Databank contains information about the shapes of proteins shared by researchers. The artist used the plaster print to mould the chocolate. The confections are part of the Sentimental Objects in Attempts to Befriend a Virus series. The truffles do not carry hepatitis C. Each one was lovingly handmade from 72% Belgian roasted cocoa in an attempt to befriend the virus. Over 200 million people around the world live with hepatitis C. Artist Caitlin Berrigan said she was sick of fighting with her virus, so instead she wanted to domesticate her untamed virus by offering it comfort, bread and circus. Instead of starvation, she offers it delicacies. The desire to eat them is mixed with a repulsion for the virus, a dialectic which has proved to be exciting in an approachable way to ignite discussion and create awareness about an extremely prevalent and underrepresented disease.
Ever had trouble adjusting to a new time zone or putting the kids to bed when daylight savings begins? Darren Osborne speaks to Dr. Sarah Blunden from the University of South Australia about body clocks and how to get the little blighters into bed without such a fuss.
Our body clock is our own internal rhythm of sleep and wake. We have a hormone called melatonin that is secreted by the dark and suppressed during the light. And this is a trigger for our body clock mechanism, which is in the back of the pituitary gland in the brain, to say it's time to wake up or it's time to sleep. So I guess you could really call our body clock part of our brain that actually regulates when we're sleepy and therefore we sleep, and when we're not sleepy and therefore we wake up.
Now, you mentioned in the press release that we need to adjust our body clocks, particularly at the end or the start of daylight saving. Why is that important for children?
And it's important for children because children seem to be more affected by loss of sleep than we do. They may lose an hour or so of sleep, and they seem to be affected in the daytime by showing signs of tiredness. In younger children, particularly hyperactivity and irritability, and older children maybe just oversleepiness. Adults have got more strategies to be able to deal with that loss of sleep. They pump themselves with caffeine, get themselves moving. They have more strategies, and children have less strategies. So therefore that loss of sleep seems to affect them more in terms of their daytime performance.
Now, recently, many parts of Australia ended daylight saving and other parts of the world started it. You recommend that, particularly for children, that we don't necessarily put them to bed at exactly the same time as we did before that change in time zones. Does this mean it gives kids a green light to stay awake until they actually feel tired?
Well, I mean, I guess it's a bit of a catch-22 situation. Because we changed the clock on the wall, it doesn't mean to say that our body clock, our internal mechanisms, actually know that that's happened. So our body clock, our internal mechanisms, still carry on the way that they were carrying on before, with or without the clock on the wall. So if that means that we move the clock forward or back, as it happens, we move them back this time, it's not quite so radical as when we move them forward. But our body clock says we're tired when maybe the clock on the wall doesn't say the same thing. So we have to be aware of the fact that if we're tired earlier or later than the body clock says it's our actual bedtime, that's probably because our body clock hasn't caught up to the clock on the wall yet. Likewise, in the morning, children may wake up more tired or less tired, depending on which way you're moving the clock. than they did before because their body clock is still on the old time. Does that...
I mean, there are occasions, though, when children might feel a little bit hyper. They've done something exciting during the day and they don't want to go to sleep. Is that a similar sort of thing? Or...
That's right, yes, that is right. Young children show signs of hyperactivity as opposed to overt sleepiness. So if parents think that they've suddenly got a lease of life and they're not ready to go to sleep at all, it may in fact be signs of tiredness. So I guess we're only talking about an hour difference here. So I often suggest that if the child is tired at 6 o'clock and they go to bed at 7 o'clock, I'm talking on the clock, then maybe we sort of edge them into a little bit later bedtime or a little bit earlier bedtime by 10 minutes a night, rather than do a cold turkey 1 hour, because that means that the child may either lie awake in bed and not sleep or fall asleep too early and then wake up early the next morning.
Now, one of the other strategies that you mention is, particularly in the morning, getting the kids outside in the early hours of the day. Why is that?
That's because our melatonin, which is one of our regulators of sleep-wake patterns, is affected by light. So if we go out into the morning sunlight, which apparently is the most potent in terms of regulating our rhythms, between 6 and 9 o'clock in the morning, our melatonin will be suppressed. The earlier it is suppressed, the earlier it rises in the evening. So what we would be doing would be regulating our body clock in terms of the light as opposed to the clock on the wall. So by going out in the mornings, the body will understand it's okay, it's actually wake time now, so they'll suppress melatonin, and at night, the melatonin will rise earlier.
When do you think is the best time for kids to go to bed?
Well, I mean, it really depends on the age of the child. Sleep is very developmentally related, so children who are older need less sleep. We still actually don't know how much sleep children need. We haven't got a regular time on that. We do know that when they don't sleep enough for them, they are irritable, cranky, hyperactive, they have poor memory, etc. So we know each parent knows that when their child hasn't slept enough, that they show the signs of tiredness. It's normally that a child would need to have about between 10 and 12 hours sleep, a primary school child, 10 and 12 hours sleep per night. So that means they're getting up at 7 in the morning to go to school. So they probably need to be in bed by 7, 8, 9, somewhere around there, depending on the child. Not everybody sleeps the same.
Now, we've been concentrating on daylight saving and time zones, but does any of this research or any of these findings apply to people who are, say, jet setters who are travelling around the world or changing shifts, doing shift work?
Absolutely. It's exactly the same thing, Darren. In fact, it's very clear that when we get on a plane and we go change time zones, we are all very tired at the time that our body clock says it's time to go to sleep. It doesn't matter when we go outside, whether it's day or night, or what clock on the wall says. Our body clock is set at the rhythm that we're used to. That's a perfect example of the fact that our body clock doesn't understand that we've changed the time zone, and we have to try and trick it by using natural light, exercise, melatonin suppression, all those things. When you're jet lagged, the best thing to do is to try and establish your new day where you are and use the light and exercise to keep your body awake so that you can readjust your body clock.
And finally, for those people who do find it hard to sleep at night and find it hard to nod off, what are some of the best strategies?
I guess one of the first things I would do for all of us, adults and children, is to make sure that we have a wind-down time before we go to bed. Many of us are working hard. We have lots to do. We need to give ourselves time. We need to give ourselves a break. So wind-down time may be a book, maybe a bit of relaxation, maybe a hot bath, something that will allow our body to understand, okay, it's sleep time, and give ourselves the opportunity to relax. That's easier said than done for a lot of people because a lot of insomniacs have a lot of stress and anxiety about sleep. But I guess if you can't sleep, then you go through the checklist of making sure you didn't drink coffee, you didn't watch TV or play on the computer an hour before bedtime, you didn't do strenuous exercise an hour before bedtime so that your body temperature rises hugely. A whole range of what we call sleep hygiene tips that can give your body the opportunity to sleep. If it doesn't sleep, then maybe there's something else going on.
That was Dr. Sarah Blunden with some tips on a good night's sleep. 50 years or so ago, the first laser was seen as a solution in need of a problem. Today, they're ubiquitous in CDs and DVD players, in laser printers, and at supermarkets on the barcode scanners. But the laser's heyday is still with us, and more amazing applications are appearing every day. Professor Harald Giessen is a laser physicist at the University of Stuttgart and is visiting Australia as a Denson Distinguished Visitor at the University of Sydney School of Physics and the Centre for Ultra-High Bandwidth Devices for Optical Systems, or KUDOS. His main research interests include white light lasers, ultra-fast nano-optics, and metallic metamaterials. Whoa. In a public talk for scientists, students and ordinary folk off the street at the University of Sydney this week, Professor Giessen explored the next generation of lasers. They're getting smaller, more powerful and threatening to make fact out of science fiction, creating X-rays, sending secure quantum signals and trapping individual atoms for us to experiment with. Professor Giessen told Diffusion reporter Chris Stewart about how we may soon have lasers better than the lightsabers, able to cut through metal, skin and bone, and take X-rays in real time, changing medicine and mechanical engineering as we know it.
So my name is Harald Giessen and I'm from University of Stuttgart in Germany, and I'm mostly working on ultra-fast nano-optics, which deals with ultra-fast lasers and with really small objects, nano-objects, mostly small metallic particles. And I came here to visit University of Sydney and kudos in order to work with Ben Eggleton and his group on the ultra-fast laser part. And his special topic is so-called photonic crystal fibers. This is little fibers, glass fibers, that have holes in them. And I actually wanted to be the first to fill them with liquids.
Well, we can maybe get to some more details of that one in a second. Your talk here today at the School of Physics at the University of Sydney was titled Beyond Lightsabers. Now, I'm guessing that all of the Star Wars fans out there are a little bit disappointed. We're not talking real lightsabers here, but we are talking about the future of lasers. What are the big applications of lasers at the moment?
Well, I would say actually we are talking lightsabers, because if you look at this old James Bond movie, Goldfinger, he had a lightsaber there, kind of, because he wanted to cut James Bond in half, and that is pretty good. That is a pretty good lightsaber, actually. So,
and we can do that now. We can cut people in half with a laser.
We could. I mean, if you stick your hand into a laser cutting machine, that's going to chop off your hand. And I have shown in my talk, actually, using the laser, that you can cut through bones, you can cut through skin, you can cut through eyes. So this is as good a lightsaber as it gets.
So there's a lot of medical applications of lasers at the moment. I mean, most people at home will know a laser from their CD player or their DVD player, but there are a lot more applications than that. What are the main applications of lasers in medicine at the moment?
In medicine, I would say the largest numbers are in eye surgery. You have your eyes lasered, so they cut a piece of your cornea off and laser part of it off to reshape it, and then they close that flap again. And laser skin treatment, that's a really big thing in America. Laser hair removal for every lady who wants to have nice legs, and even some guys want that without the hairy chest. And
but these are all fairly cosmetic things, although very important, I'm sure, to the people who are receiving the treatment. But lasers are used in normal surgery as well.
Yes, especially cutting bones with a high precision, and also for dental replacements and dental inlays. That is something that I wouldn't call cosmetic. Of course, cosmetic is also tattoo removal in a way, yeah.
So looking to the future then, what are the future applications of lasers? Where are we going to go with this wonderful piece of technology?
Well, I think lasers become more abundant every day in everybody's daily life. And what we will see is X-rays generated by lasers. So you can imagine walking into an X-ray machine and you won't feel very much anymore. It won't hurt you. The X-rays go right through you, but for just a very short time. And they can take like a real-time X-ray of you. And the other big thing is communication. So secure communication, so-called quantum communication, that is where laser research is going now.
And this is the sort of thing that you're doing here with the Kudos group at the University of Sydney. Where are we going with that? Tell us a bit about your research.
Yeah, that's right. We really want to do what we call the all-optical network, because right now you need some lasers, you need some fibers, but you also need some detectors, then you need electricity, and you always have this change of electricity and optics, and electricity is never as fast as optics. So if you want higher data rates, video on demand and so on, you need all optical networks. And these fibers that I helped to develop here, that are liquid-filled together with the Kudos people, they will enable these faster all optical networks.
And how much faster are we talking about here? Is this going to be another revolution in communication, similar to the semiconductor revolution about 50 years ago?
Yeah, I think so. This is like at least 3 orders of magnitude, which means it's going to be 1,000 times faster.
So all of our complaining about how bad broadband here is in Australia, we just have to wait for you and the QDOS team to get your act together, is that right?
Yeah, kind of.
How much further down the track are we going to have to wait?
Oh, I think that's more an evolutionary process. So if you wait just 1 year, I think you will be able to get like 10 or 20 megabits at home. But if you wait 5 years, you'll easily get 100 megabits at home. And 10 years down the track, probably gigabits per second.
Professor Harald Giessen, Denson Distinguished Visitor at the University of Sydney School of Physics and the Centre for Ultra-High Bandwidth Devices for Optical Systems, speaking with Diffusion's Chris Stewart. And finally, Kachina Allen asks, could the Aussie pie protect you against sunburn?
The classic Aussie meat pie ad shows tough men in shorts eating a pie with tomato sauce while sitting in the blazing sun. But could this quintessential down-under delicacy help to protect Aussie skins from the harmful effects of UV radiation? Sunlight can cause the formation of free radicals in the skin cells. Free radicals are atoms which exist with an unstable number of electrons in the outer electron shell. Ultraviolet, UV, radiation can force electrons from atoms such as oxygen and create free radicals. Since the electron state of a free radical is so unstable, they are likely to react with anything they touch in the cell, be it a protein or a DNA strand. This can lead to temporary damage, such as sunburn, or permanent damage including cataracts, and even to cancers such as melanomas. Tomatoes contain carotenoids such as lycopene. These are the chemicals which give tomatoes their rich colour. Lycopene is perhaps the most powerful of the antioxidants found in any fruit or vegetable. Antioxidants react with oxygen and other free radicals to neutralize them before they can harm biological processes. To some extent, the more antioxidant molecules in a cell, the more likely a free radical is to hit one of those before hitting a vital part. Putting carotenoids, especially lycopene, onto the skin has been shown to help prevent and even partially reverse the damage done by exposure to UV light. But it's not just an external form of sunblock. Leaving the sauce on your pie provides benefits too. A diet rich in tomatoes has been shown to reduce sunburn and the effects of UV exposure. In fact, concentrated cooked tomato, such as tomato paste or sauce, is an even better source of such antioxidants than are fresh tomatoes. 40 grams, or 4 tablespoons of tomato paste eaten daily has been shown to significantly reduce visible sunburn after only a few weeks. While not a substitute for sunblock or sun-safe practices, eating a diet rich in tomatoes could thus provide some level of continuous protection. Indeed, it is likely that increasing tomato consumption in your diet may help protect not only against sunburn, but the visible signs of aging, such as wrinkles, against cataracts and also against skin cancer. Perhaps in the sunburnt country of Australia, it is no coincidence that tomato sauce became the condiment of choice.
So there you go. Go home, dear Diffusion listeners, and sauce it up. And that's all we've got time for this week. Thanks for joining us. We hope that you've enjoyed all of our stories from today and learned a little bit in the process. Your science dealers this week were Ian Woolf, Darren Osborne, Chris Stewart and Kachina Allen. I'm Tilly Boleyn, and if you're after any of our previous shows, go to our website, which is www.diffusionradio.com. This show was recorded in the 2SER studios in sunny Sydney and is broadcast all over Australia via our friends at the Community Radio Network. Enjoy the rest of your week, dear listeners. See you next time on Diffusion.